Hello everyone, my name is Ashveer Singh. Today we are going to discuss the rest of the portion of previous lecture, that is the introduction of vehicle dynamics. In previous lecture we have discussed what is the type of studies we considered in vehicle dynamics and what is the concept of vehicle dynamics, considering the concept of lump mass. So how we can use the lump mass of overall vehicle, considering all the significant individual component mass, considering a common center of gravity for all the masses included in the exterior envelope of the vehicle. Then we also discuss what is vehicle dynamics, vehicle fixed coordinate system, what is earth fixed coordinate system, and how these two coordinate systems are related to find out the stability of a vehicle. So in today's lecture we are going to discuss what are the motion variables. Again, this topic is related to the vehicle fixed coordinate system and earth fixed coordinate system. Then what is Euler angle relationships, and then we discuss what is force system acting on a rigid vehicle. So the motion variables are the variables which defines the motion of a vehicle in linear direction as well as in rotational direction. So every vehicle fixed coordinate system have three mutually perpendicular axes, that is x, y and z. So we have six type of motion variables in about x-axis, along x-axis, about y-axis, along y-axis, and along z-axis, and about z-axis. So these motion variables are generally considered as the factors for the stability as well as the motion of the vehicle in particular direction. So as we can see in the figure that there is an axis, that is x-axis, the called for the forward velocity, y-axis for the lateral velocity, and z-axis for the vertical velocity. So linear component along these three mutually perpendicular axes termed as forward, lateral and vertical velocity, and these are the linear motion variables. Then if the rotation is about x-axis, that is called as rolling velocity or roll velocity. If the rotation is about y-axis, then this is called as pitching, and if the rotation is about z-axis, that is called as yawing. So we have three linear motion variables and three rotational motion variables. So for consideration of vehicle fixed coordinate system, three linear motion variables are considered in terms of small x, y and z, and three rotational motion variables are considered as q, p, r, and termed as roll, pitch and yaw respectively. So if we are taking a turn, or vehicle is taking a turn, so there will be a difference of weight between inner wheel to outer wheel. So we can say vehicle is leaning towards outside, and this leaning is about the forward axis, that is x-axis, and termed as rolling. Then if we are accelerating or braking sometimes, so the tip of the vehicle will lean forward in case of acceleration and raise upward in case of uh, lean forward in case of braking, and uh, lift upward in case of acceleration. So this type of rotation about y-axis termed as pitching. Then if we considered the oversteer or understeering, that is because of the traction on front wheel on the rear wheel, then the vehicle will stable on its track and unable to maintain the track. So in that case, the vehicle will rotate about y-axis, and this rotation of vehicle about y-axis termed as yawing. So in that case, we have six motion variables, in which three are linear motion variable and three are rotational motion variable, and these six motion variables are identified to define the stability of a vehicle linearly and rotationally. Then what is Euler angle relationship? Euler angle relationship is between the relationship between the vehicle fixed coordinate system to the earth fixed coordinate system is defined as Euler angles. So as we can see in earth fixed coordinate system, the forward travel is considered with capital X, Y for the travel in the right or any lateral direction, and capital Z for the vertical travel, and generally it is positive in downward direction. So if the angular relationship between small x and capital X is termed as heading angle, the angle between vehicle velocity vector and capital X, that is called as course angle. And if the angle between the x-axis, small x-axis, and vehicle velocity vector, that is called as side slip angle. So as we can see in this figure, that this angle, this is the x position, the forward motion vector of the vehicle, and this is the projection of the instantaneous velocity while we are taking a turn. So with respect to this angle up to from x projected to the this reference line, that is the angle called as heading angle, then the angle from here to this projection instantaneous center, that is called as course angle, and that is considered positive. And the angle between this projection of instantaneous velocity and the x projection, that is termed as side slip angle and termed as beta. So Euler angle are determined by the sequence of three angular velocity or rotational, begins with yawing, then pitch, and then rolling. So first the stability of a vehicle will define with the help of yawing, then pitching, and then rolling. So this is the sequence. Now the force system acting on a rigid vehicle. In that figure we can see there is a vehicle taking upward direction, uphill direction, having an inclination theta with the ground surface, and this is the angle theta. This is the center of gravity of the vehicle upon which the overall lump mass or the weight of the vehicle is concentrated. Then it has two component, like cos component in the downward direction and sine component in horizontal direction. This force, that is for the acceleration component of the weight of the vehicle. This the aerodynamic force on the front face of the vehicle as vehicle is moving in forward direction. So air will create a resistance against the motion of the vehicle and create a dynamic force over the front screen of the vehicle. If we consider that this is the CG, so this overall weight of the vehicle will distributed on front and rear wheel axle. So we have two reaction, WF on the front wheel and WR on the rear wheel. So and then again we have the reaction due to the traction of the vehicle, that is called as RX in the front wheel and RXR on the rear wheel. Then Fx is the frictional force in x direction on front wheel, and Fxr is the frictional force on rear wheel. Then again if the vehicle is towing something, then we have two components of forces, first in vertical direction, downward direction, that is R reaction at hinge point in Z direction. So RHS is the reaction at hinge point in Z direction. Then RHX is the reaction at hinge point in x direction due to the pulling of the pulling of the trolley or any vehicle. So as we can see, this is the wheel base of the vehicle, that is L, and B is the distance from front axle to the center of gravity, and C is the distance from the rear axle to the center of gravity. So by identifying the location of center of gravity, we can identify the dynamics of force and equilibrium of forces. According to that, we can design our vehicle on the basis of wheelbase B and C, that is the dimensions of distance between front axle to rear axle, or you can say the length of the vehicle. So that is all for today. Thank you very much.